Okay, here are the notes for section 3.3. I'm going to zoom in. Okay, and the notes are function notation. Okay, so to start off with, function notation is a fancy way of saying the y equals. Okay, so what's going to happen, you're going to have this new little thing that says f, this is called f of x. Sometimes it'll have different letters like g of x or h of x, but this is the main one we're going to be using. And it's the same thing as y equals. So for instance, if I gave you a problem that looks like this, y equals 2x minus 7, a new way that it's going to be written is going to look like this. It's going to say f of x equals 2x minus 7. And these literally mean the same exact thing. So if I wanted to give you a problem, let's say I said evaluate when x equals 4, and you had to figure out what to plug in. So we're basically going to be taking the 4 and we're going to be plugging it in everywhere that we see an x, which are in these two places, which means the function at 4 is 2 times 4 minus 7. Okay, I just took a 4, I plugged it straight in there, plugged it in here. Now, if I do the math on here, 8 minus 7 makes 1. This is the solution to this, which will be 4, comma 1. This is the x point, this is the y point. The resulting answer is basically your y value, which is f of x. These are equivalent things. Okay, so this was step A, if I decide to make this one x equals 4. Now for part B, let's say I made x equal to 1. Okay, so now if I go here and do the same thing, I'm going to be plugging in 1 for the x. Well, this would make 2 minus 7, which makes negative 5, which means that the point will be 1 comma negative 5. And the reason why we're doing all these is because we want to be able to plug these into our function here to figure out exactly what the points are. So you have on your homework, you're gonna have a lot of problems where I'm gonna give you x points or x values like this one. And there's gonna be functions that you have to plug it into. So we're basically introducing function notation, which is the same way or same thing as y equals. So now if I took f or x equals negative 3, that means everywhere that I see an x, I'm going to plug in a negative 3, which will look like this. And when I put those together, I get negative 13, which gives me that answer. And those are all the solutions when I plugged in x being 4. When I made x 1, that was my resulting answer. And when I made x negative 3, there was my resulting answer. Okay, so that was like the first example. Here's the second example. Let f of t be the outside temperature in degrees Fahrenheit T hours after 10 a.m. Okay, explain what each answer means. Okay, so now every once in a while, instead of having f of x, you might have something like f of t, because in this one, we're going to be talking about temperature. So we're going to use the letter T, and we're talking about degrees Fahrenheit. Okay, so here's the first thing that we're going to be looking at. It says f of 0 equals 75. Okay, so what we're doing here, and we have to interpret what this means. This is telling us that our temperature at time 0, when time is 0, it's going to be 75 degrees. So now remember that our starting time is at 10 a.m. So this is telling us at time 0, which is our starting time, at 10 a.m., it is 75 degrees Fahrenheit. That's what this statement means. Okay, whatever this number is the amount of hours after 10. Since it said 0, it means it's the time at 10. Okay, now for part B, if I said f of 2 equals 83. Now, what does this mean? The 2 represents 2 hours after 10 a.m. So that means at 12 noon, the temperature is 83 degrees Fahrenheit. Okay, for part C, f of 3 is equivalent to n. That means it's unknown. We don't know what it is. So we need to figure out what time this says. Well, it's 3 hours after 10 a.m. So at 1 p.m., the temperature is n degrees. We don't know exactly what it is. Okay, that's what the n stands for. Okay, now for the last one, choice D, I'm going to move this up a little bit. It's going to have some weird stuff here, which looks like this. F of 1 is greater than f of 8. So we got to figure out what this time is. Well, this is 1 hour after 10. So this is at 11 a.m. That's greater than whatever the temperature is at 8 hours past. Well, if I took 10 and added it to 8, okay, remember it's 10 a.m. at 8 hours, that should go all the way to 6 p.m. So that means the temperature at 11 a.m. is greater than temp at 6 p.m. Okay, now these are some of the things that you're going to see when we start doing some problems. You have to interpret what these numbers mean. The values that go here, the 0, the 2, the 3, the 1, the 8, it's all from a starting position. Now, you could also have negative numbers here. If this would have been a negative 1, that would have meant 9 a.m. Okay, so now let's take a look at, we got some more things here. We're going to go to example 3. Okay, g of x, we've got a different one, is equivalent to this. Okay, now it's a different one, not f of x anymore. It's now g of x, and we have a strange formula. Okay, and the thing says, find the value of x for which g of x equals negative 4. Find the value of x for which g of x equals negative 4. Okay, this thing is telling us, here's g of x, that is negative 4. So now we just need to solve this. We're taking negative 4 and we're plugging it directly in place of g of x. G of x is negative 4, so it plugs into there. Okay, now this is stuff that we've done before. To isolate the variable, you got to get rid of one of these two things first. Remember, you got to get rid of the constant first. The opposite of negative 2 is positive 2. So we're going to start off by adding 2 to both sides. And this will make a third x is equivalent to negative 2. To undo a fraction, we are going to multiply both sides by the reciprocal. These all drop out, and when I multiply these together, I get negative 6 over 1, which is negative 6. And that's my answer. That's the value that will generate a g of x value of negative 4. So if I had to write this as a point, x is negative 6, and this little point, this is basically the y value, is equivalent to negative 4. That is the solution of where that thing would cross at. Okay, example 4. Graph the linear function. Now, if I'm moving fast on these, remember, you can always pause these and rewind it and look at it again if I went fast when you look through these. That's a nice thing about having the videos. You can always rewind and look back at them. And you can also look at this while you do your homework to find what problem is similar to whatever homework problem you have. Okay, so now the first example that we have an f of x is equivalent to 2x plus 1 that looks like this. Now, I'm going to start this by making what's called a t-chart or a table. Okay, and you may remember from maybe from middle school, you had a little thing with an x, y, and we're going to plug some points. These are the points that I like to plug in. Now, all you need is 2 of them, but I'm going to use 5 because I'd like to plug some of these numbers in to see what answers we get. Now, I'm going to start with the easiest one I can find. Negative 2, negative 1, 0, 1, and 2. I'm going to start with 0. All that means is I'm going to take 0 and I'm going to plug it into my function and see what it makes. Well, 2 times 0 is 0, plus 1 is 1. Now I'm also going to do this one, 2 times 1 plus 1. If I put these together, 2 plus 1 makes 3. And if I do this one here, 2 times 2 is 4, plus 1 makes 5. Now, I'm going to also write the other ones down, and you might notice some patterns. Take a look at the numbers. Don't all the numbers look like they're adding by 2? So if I went up the other direction, it should be subtracting by 2. And I bet you that those answers are correct. 2 times negative 2 is negative 4, plus 1 is negative 3. And this makes negative 2 plus 1, which is negative 1. Well, this is going to lead to ordered pairs. There's the first ordered pair, the second ordered pair, third ordered pair, fourth ordered pair, and the fifth ordered pair. Now let's graph this, because we want to get a picture of what the graph looks like. 2 left, 3 down. 1 left, 1 down. 0, 1, 1, 3, 2, 5. Okay, now if I graph this correct, it's going to make a nice, pretty, solid, straight line. And now, this is something we talked about or chatted about the other day. You might remember the y equals mx plus b. Well, b, in our notes from the other day, represented the y-intercept, which was 1. Look at where the graph crosses. Looks like it crosses at 1. This value is the slope. Okay, I'm going to write slope here. The slope number is 2 over 1. So that means from this point, I climb up 2 and I go over 1 to get to the next dot. It makes stairs. Go up 2, right 1. It's going to continue that pattern forever. Now you could do that from the points here to graph it, or maybe you already know how to do this from maybe a middle school class, because you probably have seen that before. So here's some introduction to some of these. We're going to do another one down here. This is the last little example for 3.3. We are going to graph g of x is equal to 3 minus x. Now, you could always do the chart if you'd like. And remember, I like these numbers. You can pick some different ones, but those are the numbers that I like, negative 2 to 2, and I pick all the whole numbers. Now, some of these should be pretty easy. If I plug a 2 straight in, 3 minus 2 should make 1. 3 minus 1 is 2. And you might start noticing a pattern here that's coming up. It looks like all these numbers are going up by 1. So I bet you if I do this one, 3 minus a negative 1, these change to pluses, this makes 4. And 3 minus negative 2, these two minuses change to pluses, I get 5. And then here are my points. Which should look like this. Now let's graph these 5 points. Negative 2, 5, which is there. Negative 1, 4, 0, 3, 1, 2, 2, 1. They make a nice, pretty straight line. Okay, if I miss your dot, make your dots bigger. Okay, there we go. Okay, so now let's check and see if these numbers look good. Y equals mx plus b. Now, it's not really truly in y equals mx plus b form. If I were to rewrite this, why don't I put the x first and put the 3 second? This is my y-intercept, the constant number, 3. Well, look at where the graph crossed. Crossed at 3. And my slope was down 1, right 1. Down 1, right 1. Down 1, right 1. It should follow this pattern forever. Y-intercept was 3. Slope was down 1, right 1. When I did my last one, my y-intercept was 1. My slope was 2 over 1. Okay, so this should give you guys a pretty good start to how to do section 3.3. Okay, so